Bye all.
Bye.
Yeah, bye.
Bye.
Hello everyone and welcome to the Maths in Space panel. We hope you've had a great day so far, learning all about science in space, technology in space, engineering in space, and finally saving the best until last, maths in space. My name's Jackie and I'm a mathematician and theoretical particle physicist from Liverpool, and I'm working in the Department of Computing at Imperial College London. Now, I've always been fascinated with space and human and robotic space flight, and that interest in space and mathematics has led me to work with some amazing people and experts right across the UK and in fact right across the world. Some of these amazing people from across the science and engineering sector are joining me here today to share a little bit about their inspiring work and research and to answer your maths and space questions. Our first panelist is Nuala O'Flynn. Nuala is the Outreach and Public Engagement Manager in the Department of Physics, Astronomy and Maths at the University of Hertfordshire. Nuala, tell us a little bit more about yourself and your career journey to date.
Yeah, hi everyone, it's amazing to be here today. I hope you can all see my screen right now, is that good? Yeah, cool. So yeah, I'm originally from Kent, but I now live in London and I studied physics and astrophysics at university. So maths was a huge part of this. Maths is kind of like the language that describes how things work in physics, astronomy, physics and astronomy. So it was a really important part of my degree. So then while I was at university, I did 2 placements in a secondary school science department, which is where I realized I really love teaching people about all things science. But I decided not to become a teacher because I really didn't want to stop learning new things about physics, astronomy and maths. So I was really lucky to find a career where I could combine both of these, which is in my job now, where I work in the Department of Physics, Astronomy and Maths at the University of Hertfordshire as an outreach and public engagement manager. So I run and manage a STEM outreach program in local primary and secondary schools, so teaching students all about science and also careers in science. And then me and my team get to work here at the observatory, at Bathory Observatory, which is the University of Hertfordshire's teaching observatory. So it's mainly used by undergraduate students. But me and my team organise events there for the public. So we do public open evenings, school trips, and group visits in the evening as well. So our visitors get to see our telescopes, which you can see here. They get to go inside our telescopes as well. They get to have planetarium shows and also get to learn about all of the research we do here in our Department of Physics, Astronomy and Maths. And I absolutely love being able to do this, and I feel really lucky to have my job. It's different every day. I get to be really creative in it, collaborate with people from all across the UK and sometimes around the world as well, and to share my love of science with others. So yeah, that's my job.
Thanks, Nuala. And for all the children watching, all the schools, all the teachers watching, how can they get involved in some of the work that you do? Can they pop along any day to see all the science in action, or give you a call and book a visit? What should they do?
Yeah, so I have a slide actually with all my socials up. So if they want to visit our website here or follow us on Instagram or Facebook or Twitter, then you can find out all of the ways that you can come and visit our observatory. So there's all that information there if anyone's interested. We would absolutely love to have you.
Brilliant. And before we move to our next panelist, I just want to ask you a few things. You talked a little bit about what you enjoy about your job, but what's your favourite thing about working in the space sector?
I think it's definitely all the different people that I get to meet. So I meet people from the age of, well, babies to very, very old adults as well. And I love that. I feel like everyone has this sort of like fundamental curiosity about space. You know, it's something we see. We can see the moon every day, pretty much. We can see stars as well. And I love being able to help people explore that curiosity they have around space and answer any questions that they have, but also like sharing our learning as well. I still learn so much about space all the time and from the people that I interact with. So I think that's my favorite thing about it.
It sounds really good. Very similar to my job, especially if you're a people person. This sector is definitely a good one to get involved in. So thank you so much for that, Nuala. Our next panelist is someone very special indeed. So our next panelist is Mark Boyd. Mark is a PhD researcher in planetary science, right here at Imperial where I am today, but over in the Earth Science and Engineering department. So Mark, I can see you've uploaded your slides. Tell us a little bit more about your research.
Thanks so much, Jackie. Yeah, so my name's Mark and I'm a PhD student here at Imperial. Previously, I was at Durham University where I did my undergraduate in natural sciences. And in that degree, I did a bit of chemistry and I also did a bit of earth science. But throughout all of that, the maths was really the glue that kind of brought all the different science together. And as I moved into my master's, I studied in the States. And started to kind of learn a bit about planetary science. And again, that maths was so important in kind of grounding the science that we were doing. And that's when I began to look at stuff from outer space. So I'm sure many of you have heard of meteorites. These are rocky objects that have come from the solar system and landed on the Earth. Well, I look at things called micrometeorites, and you can see a picture of one on the screen here. These are just tiny little bits of dust that have come from space. So this one is about the width of a human hair, but you can see there's a really interesting amount of detail and lots of exciting things going on, and I could talk for ages about them. But I use these little bits of space dust to understand the environment out in the solar system as well as on the Earth. So these little bits of dust are normally debris from asteroids. They're sometimes also shed by comets. You might have seen the tails coming out of comets. They're just shedding dust, and these can arrive at the Earth. And actually, they're arriving all the time, everywhere. So you might have some on your clothes or on the roof of your house or school. And there's about 10 that fall every square meter every year. And they give us quite a lot of information, each one a little bit of information, but about a lot of things. And they can tell us I like to think they're our cosmic messengers or solar system storytellers. So, you know, I use these to understand how environments are changing, what things are made of in space. It all sounds very exciting, hopefully, and it is. Things aren't always easy. These things are really, really tiny. If you had it on your finger, it would just be a little speck. And oftentimes, if you sneeze or breathe when you're handling them, they're gone. And you're going to have to go and find some new ones. So they're very easy to lose, but the science you get out of them is so rewarding. And as I've said, the maths is so important throughout that process of finding them, understanding what they're made of, and trying to work out what they can tell us about the solar system.
Wow, I mean, that's really impressive. So I didn't know how common these things were, that we could be breathing them in all the time without realizing. So how do you know how, like if I was to sweep the desk like this now, how would I know if I've found a micrometeorite? How do I find these things?
Yeah, that's such a good question. So normally when these things enter the atmosphere, they get heat up by friction. So just like when you rub your hands together, things get warm. And then they'll melt and re-solidify as a ball, like you can see in this picture here. So you're normally looking for spherical things. And they also contain lots of metal, so iron and nickel, for example, which makes them quite dark in color and magnetic. So we can use a few techniques, just like hovering a magnet over some dust to try and pick these out. But obviously looking for them around my desk in particular, there's a lot of other rubbish here. So you have to be careful of what you're picking up.
Wow, I can just imagine everyone is now on the hunt for meteorites. What do they, can we feel them? Can we smell them? Can we taste them? Like, how do we, what are they like?
Yeah, so they just look like any other dust, really. When you're kind of looking at them in your hand, they would just feel a little bit gritty. But it's when we get down to this kind of micro scale detail, and I can take an image like this, you might be able to see sort of little Christmas tree shapes on this particle in particular, and that tells us about how it cooled and what kind of crystals there are, what its composition is, and we can pick it apart and do all sorts of chemical analyses on it to understand how they formed. But you can absolutely go into the gutter and kind of try and find any little black particles. You might be able to find some dust from space that's probably billions of years old.
Wow, and we've already got lots of questions coming in about this, which is very, very exciting. So before we start digging into those questions, I want to introduce my final panelist of the day, but by no means least. So our last but not least panelist, we have lead electronics engineer Paula Maddox here today to tell us more about her amazing work at Spaceforge Limited. Over to you, Paula.
Thank you. So my name's Paula. I work for a company called Spaceforge, and we are doing a platform that you can send to space to manufacture various things where you don't have any atmosphere and you don't have any gravity, and then you can bring it back down. We can refurbish the satellite and send it up again, so we can reuse the satellite multiple times. My job is lead electronics engineer, so it's my job to make sure that all the bits of wire go in the right places and the right components go to the right parts, and things don't catch fire or explode whilst they're in space. It's quite a challenging job. It's really good fun. It's not a job I ever imagined I'd be able to do. But yeah, I'm really glad I am doing it, and it's such an interesting environment to work in. I know others have said, but every day is a school day. I'm always learning something new. And that's, for me, is one of the great fun things about having a job like this.
Wow, thank you so much. And you say that you couldn't imagine yourself in this job before. Is that because you didn't know much about the space sector, or you were interested in maths but didn't know how it formed part of the job that you do now?
So I use maths every day for my electronics, for calculating currents, working out how to do different filters, for sampling signals and measuring pressure and gravity and that kind of thing. So I do use them every day. But I knew nothing about space up until 2 years ago when I started working at Spaceforge, and I kind of had a crash course in it. And there's a lot to learn, and yeah, I'm still learning, and that's really fun. That's the best part of the job.
Yeah, I agree, and I think we're nodding away that a big part of our roles are, we continue to learn every day. Learning is not something that ends at school; like it's only just beginning, which I think is the most exciting part about growing up, really.
Yeah, very definitely.
So we've had a few questions in. I'll stick with you, Paula, for the time being. Someone has asked how long it can take to build a satellite. So I'm assuming this can be a long time based on how long it takes to test things like the Webb Space Telescope and big satellites like that. How long does it take, sort of on average?
It's a good question, and I would say it very much depends on what you're building. The James Webb Telescope took years. However, our first satellite, which we launched back in January, took us 5 months to build, which I think created a record for the fastest ever satellite build. But I think normally they're sort of 2 to 3 years is fairly normal. There is a lot of design work, a lot of consideration, and as you said, there's a lot of testing. How different materials behave when they're in a vacuum, or when they're at minus 200 Celsius or plus 200 Celsius, which can happen when they're in space. So yeah, there's a lot of testing that needs doing.
Definitely, and apologies if you can hear the siren in the background. I was waiting for it to go past, so you can never predict these things. And so from small satellites to big satellites, then I guess Spaceforge is involved in a lot of different things.
Yeah, so we're bringing our own platform for manufacturing. So the idea is we will be able to take someone who is perhaps doing some chemistry experiments, or somebody who wants to do some mixing of various metals to create new alloys. So we'll be able to take their experiment, put it in our satellite, send it up, leave it up there for 6 months whilst managing the experiment, and bring it back down, and then we can give the results to them so they can go away and do some more analysis on it.
Brilliant. So you're at the cutting edge of research then. You're helping these teams around the world with being able to get their results and find new things out about space.
Yeah. I mean, that's one of the main things, you know. One of the people who founded the company has a great saying that, you know, Earth is a fabulous place to live, but it's a terrible place to make things, because of all the dust and the gravity and things. So, you know, if you mix two different alloys on Earth, they'll separate, with the heavier one being at the bottom. Whereas in space, there's no gravity, so you can mix them and they'll stay together. There are a lot of benefits to that, especially when it comes to the chemistry research and things as well.
Completely agree. And on that note of dust, I think we'll come back to these micrometeorites. Someone has asked, how can you tell a difference? How do you know dust from micrometeorites? How do you know it's not just dust?
Yeah, that's such a good question, and you don't really know until you've put it under something called an SEM, which stands for a scanning electron microscope. So you might have seen a light microscope, maybe you've put bugs underneath to kind of have a closer look of what they're made of. Well, an electron microscope works in a similar way, but rather than using light to magnify things, it uses electrons. And it's really neat because those electrons can actually tell us the composition of the things in our micrometeorites and our other samples. Now, micrometeorites and other things from space have a very different chemical signature to what we find on the Earth, because on Earth we've got all sorts of geological processes. We've got subduction zones and volcanisms, and that's changing the chemistry of what we have on Earth, pretty much to give us the iron and nickel at the core, and then lots of other kind of silicate rocks, we call them, forming the crust. But in space, we haven't had that kind of processing. So actually, we get a very different chemical signature for these things coming from space. So it's kind of, that's our telltale sign that they come from space. But that's not to say that other processes aren't happening in space. You know, when asteroids were forming, some of them were starting to become a little bit like planets, for example. And so we've got geological processes going on there. So it gets complicated is kind of the answer to that. But looking at its chemistry is the way we do this.
Brilliant. So any of you interested in chemistry, this could be a nice little crossover into getting into the space sector. So we've had a few questions here from Year 8 Forrest Sandal Manor. Hopefully I'm pronouncing that correctly. One of them asks about what are the most exciting opportunities for electronic engineering in the next decade, and how can aspiring engineers best prepare for these trends? Whoever would like to take that, maybe Paula, and leaning towards you a little bit.
Yeah, that's a really good question. So the UK is really great at innovating, and the space industry within the UK is growing really, really quickly. When I joined Spaceforge 2 years ago, I think I was 10th or 11th in the company. Now we're up to over 50 people. We're looking at a big site in South Wales. So it's growing really rapidly, but it's not just us. There are other companies. There's 2 launch companies as well. And electronics is everywhere. You know, it goes from a lot of people's watches, their telephones, their televisions, but also radios and everything like that, all of which go into satellites. So you've got radios, you've got little onboard computers and battery packs, which is commonly like you get on mobile phones for charging. We get solar panels, again, you can see those on houses. So there's a lot of technology that comes from our everyday needs that goes into satellites. And eventually what you'll see is stuff that comes from satellites will come back down and help us on planet Earth.
Yeah, that's very, very true. And we've already seen a lot of that technology that has been designed, for example, for the International Space Station that has come back to Earth. And, you know, we've been able to have better filtered water systems for, you know, developing countries, for example, all because we had to make this technology compact and we had to make it work in special conditions in space. So you're exactly right. And yeah, any of you budding engineers out there, there's definitely plenty of scope to be developing technologies that will then impact us, both in our sort of healthcare, but just human life in general back on Earth. So we've got lots of questions. I'm going to try and get through as many as we possibly can. One that we've got from Finley from Inkscape House School. Thank you for your question. You've asked about how ICT is useful in the space business, and I guess working in the Department of Computing at Imperial, I can start that one off, and then we can ask our panelists to contribute a little bit. So I think, as Paula was saying, you know, you have all of these devices on your spacecraft, down on Earth, and mission control, on your satellite, read and data, all of the instruments that you have on satellites. All of these need computing, they need mathematics, and, you know, a big part of computer science, which I always tell schools and anyone coming into computing, is maths. Basically, if you can do mathematics, you can do computing, and you can develop these systems on board spacecraft or on board satellites and telescopes and all kinds of things. So ICT and computer science and mathematics play a huge role in the space sector, hence why we have this amazing panel with all of our amazing panelists talking about the impact that maths has. So I'm going to, unless anyone else would like to chip in, I might go straight to some more questions then. Hopefully that answers your question, Finley. Thank you so much for asking that. Let me see where we are. Okay, so I'm going to ask you, Nuala, let's come to you. So what is the most exciting project that you've worked on in your career? And do you have a significant challenge that you faced in that project?
Oh,
good question.
Great question. Yeah, I think my favorite project that I've worked on has been a project I did with libraries in Hertfordshire. So we run a project together where we did astronomy storytime sessions for children aged 4 to 7 and their parents and carers. So each session was themed around a career in astronomy or space science in general. So, for example, we had one about an astronaut where the children would get to hear a story about an astronaut, and then we would do an activity based on an astronaut, so the children and the parents could really experience what it was like to be an astronaut and learn all about the qualities needed to be one as well. So that was really fun. I think the biggest challenge with that project, I think it was making actually all the astronaut glove boxes for it. I had to paint them all individually, fill them all with sand, transport all that sand to the library, and then the sand just went everywhere. So it was super messy. So I think that was actually the hardest part, but that was an amazing project and it was so fun doing that. Yeah.
Oh, it really sounds amazing. I guess as that project ended now, is there any legacy from the project people can get?
Yeah, it is still finished now, but all of the activity booklet is all online still. It's called Cosmic Curiosity. So if you just Google Cosmic Curiosity, our pages will come up and you can see all the activities that we made for that, all based around these different careers in space science. Yeah.
Fantastic, brilliant resource for you there to check that out. I'm going to ask the same question to Mark, actually. So what's the most exciting and challenging project that you've worked on?
Yeah, that's such a good question. I've had the benefit of having some time to think about that. I think one project that I've really enjoyed was during my master's research, because of the technique I was using. It was something called atom probe tomography. Now, there's some big words in there. Basically, what it lets you do is work out where individual atoms are within your sample and what they are, effectively what elements they are. And we did this on a micrometeorite. So basically, you're taking something that's tiny and then you're getting even tinier information out of it. And the potential of this technique is absolutely phenomenal, getting to see things on the nanoscale. But there were huge challenges in handling such tiny things. Remember, I said, you know, these are little specks of dust about the width of a human hair. So really challenging to kind of get the information we want, and getting a huge amount of data and trying to work out what's what elements are what. But that's where the excitement comes in, really, kind of doing that problem solving. It's such a fun opportunity to kind of, this is the cutting edge of research. No one's ever looked at this particular micrometeorite before, so it's such a great opportunity to just explore the science.
And it's such a good point that you make there. There's still so much science that we haven't even started to explore, or we've begun exploring, but we haven't even got halfway through what could be possible. So there's definitely plenty of things out there for you all to be exploring. I wanted to ask something that you mentioned, Mark. So you're saying about zooming in and zooming in and zooming in. And I guess as a particle physicist, I'm quite interested in that. And I know that we traditionally need really big machines to be able to do this, big processing power to zoom in and see the real small things. If I wanted to start looking for these micrometeorites, and I'm going to pick the best microscope that I can from the catalogue, what is the best high street microscope that I could buy to maybe help me out with getting started with some of this science?
Yeah, I don't know kind of makes and models in particular, but there are some really great opportunities to buy secondhand microscopes online. So you'll be looking for ones called stereoscopes, because they have kind of the right magnification that you will need to look at your dust particles or whatever else you want to look at. So stereoscopes, they're made by people like Zeiss and Nikon and Leica, and many other brands I'm sure are available. And these let you kind of zoom in sort of 6 times magnification. If you want to look and kind of narrow down your search a little bit before you get to the microscope stage, I'd recommend a sieve. So you're looking for stuff that's smaller than about 0.5 millimeter. I just have a little tea strainer that I use, and also a magnet. And that's kind of all you need to begin your micrometeorite searching journey.
Brilliant. I asked that for my own benefit because I'm really interested in finding these things. Something good to add to the Christmas list, it might be a way off. We've been asked a little bit about what our qualifications are to get into this job. And I know, Paula, you mentioned that this maybe wasn't the career that you thought you'd be in, and maybe a lot of us can sort of agree. Me definitely didn't know I was going to be working in computer science. So let's maybe we should go around and talk a little bit about our qualifications, our GCSEs, A levels, and things like that. So maybe starting with you, Paula.
Yeah, thank you. So I came by a slightly non-traditional route. So back in the day when I was at school, we had O levels. So I've got 5 O levels and a few GCSEs. One of those O levels is in maths, and then there's a couple in science, one in computers, and one they called craft design and technology at the time, which was kind of woodworking, metalwork and electronics all thrown in together. From there, I was very interested in electronics, so I went to college and I did what's called an HNC, a Higher National Certificate in Electronics and Telecommunications. And then I went off and got a job. So I don't actually have a degree, but I have spent 30 odd years working and building my sort of CV up and have got a lot of experience from a number of different careers. I spent probably 25 years of my life working in computers, but still building electronics in the background, and then switched career. So yeah, it is possible to switch career, and I think having a lot of experience helps. A lot of companies ask for qualifications and university degrees and things, and I think those are really good and they're really important to have. And certainly I wouldn't be able to get the job now if I was younger without having a degree. So it is very important to have a degree. But if you're willing to wait a bit and move around a bit, you can probably get around without one.
Yeah, so I think it's nice to talk about the different routes actually, because there are some great sort of internships and apprenticeships that you can do, and I always say to people, have a look at those before you start looking at your degree programs and your A levels, especially if you're a very hands-on learner. I think it can be really, really valuable actually to get into a company and experience it sort of firsthand, and then maybe later you can always go back and do that degree or do that degree part-time if it's something that you need to progress.
Yeah, very much so. I mean, we have a space intern program that I know there are a number of them around, so we do have interns come and work for us.
There you go. So anyone who's interested, get in touch with Paula. I'm sure she'd be delighted to show you around, get you involved. Let's go to Nuala next. Tell us a little bit about your background and how you got into what you do.
Yeah, so I did GCSEs, and then for A-level I did physics, maths and biology. I actually didn't get into my first choice university from that because I messed up one of my maths A-level exams, so I got a lot lower than I was expecting, and ended up going to Sheffield, which I was very happy about in the end because they had a real focus on that education outreach in their department. So I got to learn a lot about that, did a whole module in it, and I did 2 dissertations because I'm crazy. One that was on an astrophysics project looking at galaxies and different types of galaxies, and one of them was on the reasons why women continue with physics post 16. So sort of both of those experience that I had. I also got the opportunity, like I said, to work in a secondary school, to go on a summer school as well about gender diversity in physics. So all of these kind of experiences came together and gave me the relevant experience to go on to a job in physics education and outreach. But I wouldn't necessarily say a degree is essential for my job. I think that just being able to sort of have that passion for science and be able to communicate it well, communicate complex things well, because I now work in the School of Computing, Engineering and Physics. So I do a lot of engineering and computing outreach as well, which I've never done. I haven't studied at all, but it's just about being able to communicate complex ideas in interesting and fun ways. I think that's the most important skill for my job.
Brilliant. Couldn't agree more. I do a lot of that in my role as well. So I think if you're good at communicating, you can express yourself well, you're quite creative with how you express yourself, then yeah, it's definitely, you know, I was going to say the sky is the limit, but maybe the universe is the limit, and beyond. So Nuala, I've been a little bit observant here, and I've noticed your very on-brand earrings and jewellery. Is that the Webb Space Telescope I see?
It is. So this, I don't know how well you're going to be able to see them, but this is, yeah, the James Webb Space Telescope, the primary mirror on it. These are my earrings now, and I absolutely love them. My colleague, who actually works in web research, she got these for me as a present for my birthday. So, and I wear them all the time now.
They're so lovely. And yeah, if you're unfamiliar with the Webb Space Telescope, it is great. Going to be getting us some fantastic results, hopefully, to talk about how galaxies were formed, the beginning of the universe, maybe if there's any other life out there, who knows. But it's got a really cool, interesting maths fact, and that is that at the point at which it sits at is known as the second Lagrange point. And there's 4 or 5 different Lagrange points out there where things, you know, satellites and objects can sit, where they'll be in a perfect orbit, and they need very little propulsion to be able to keep them where they are. So have a look at that if you're interested to find out a little bit more about the Lagrange points. But it's a great way to demonstrate how maths is just out there in the universe, and we can sort of take advantage of that if we know enough about it. Mark, tell us a little bit about your background, your GCSEs that you did and so forth.
Yeah, I'll just share one theme, I think, from my story and my background is that the field that I am currently in or have been in, I didn't know about until I got into it, really. So when I went in to do my undergraduate degree, I was not really aware of geology and earth science, but I'd really enjoyed physical geography back at GCSE. And then I really enjoyed it when I took it at undergraduate. And again, moving into my master's and to my PhD, I wasn't really aware of the field of planetary science until I thought I could kind of came across this world of meteorites, and you can do chemistry on them, but they're still rocks. So you're doing geology, but it's all in space, which is what I love. So it's just been a progression of kind of finding these things out, and there's still so much more on the cards, and we're still learning so much about dust. We're sending a mission to Mars. This is Mars Day. We're sending a mission to learn about its moons and how the dust interacts with them. So I'm still kind of learning more, and the universe keeps expanding in so many different ways.
Fantastic. And I think we've possibly got time for one more question. So I'm going to do sort of quick fire at each of you. So let's stick with you, Mark. We've had a question that's asked, what is a meteorite?
That's a brilliant question, and I'm sorry if I dove in straight into the micrometeorite. So a meteorite is just a body of rock from space. So when they're out in space, they're called meteoroids, and then as they enter the atmosphere, they kind of glow like it's a shooting star. That's called a meteor. And then when the meteor lands on the Earth, when it's right in front of you, it's called a meteorite. So it's just a rock from space, basically.
There we go. Now we know. And Paula, a question for you from Saxon Way Primary School. Did you have to learn a lot of maths equations to be a space scientist?
Oh, blimey, good question. I don't necessarily think maths equations, but understanding the principles of maths and how you can apply them to the problem you have is something that is very key. So yeah, I think that's more than specific equations. It's understanding what the problem is and how maths can help you with that.
Perfect. I completely agree with that. As a trained mathematician, I think that is, we're not expected to remember everything. And so having the ability to look up the equations when you need them and apply them in the way that you need to apply them is more important than remembering every single fact and figure. So yeah, thank you for saying that, Paula, because I think it's a really, really important thing. And I guess Nuala, to finish off with you, we'll go with, there's a question here from Miss Miller that says, how old were you when you first started your current career and when you first decided that this is what you really, really wanted to do?
So I got this job pretty much straight out of university a couple months afterwards. So I was only 22 and I haven't left it yet, and I'm now 26. So, and I don't think I'm ever going to leave it. So I guess I was 22. I think it was sort of the year before that, when I was about 21, I sort of figured that this is where I wanted my career to go. Like people have said, I had no idea that this was a career option when I was at school, that you could like talk to people about space all the time. So yeah, that was it.
And that just, it proves a huge point that, you're picking your subjects at school, you're deciding on your career at the ages of 15, 16, 17. But actually, a lot of us have probably, done this in our careers. We've jumped from this to this to this, and there's lots of nodding. I can see everyone nodding. So it just depends where the doors open, really, and if you're willing to pursue that path. I would always say I'm a big advocate for maths, as we all are here. So if you choose maths, you can't go wrong. If you do good at your GCSEs, if you pick it up at A level, if you pick it up when you're older, you might not enjoy maths right now, but there'll be a time when you do enjoy maths and you see how practical it can be and how useful it can be in your future, in your career. I think anyone who does maths, you have all of these doors open for you right across the space sector and beyond. So on that note, I'm going to thank our panelists. I think that's all about what we have time for today from our Q&A. So thank you to our amazing panelists, to Nuala, to Mark, to Paula, and thank you our wonderful, wonderful audience for all of your questions. Sorry that we didn't get round to answering them all. Hopefully you can do a little internet search and find out more things to answer your questions after today. But for now, I'm going to hand over to Fran Scott to bring our session to a close, tell you a little bit more about what things are happening round about soon.
Brilliant. Bye all, and thank you very much, Jackie, and thanks to Mark, Paula, and Nuala as well. Thank you so much. That was so interesting. And all of the panel sessions I found really interesting, and I hope you did too, in terms of thinking and highlighting those jobs that we just didn't know existed, and seeing the people that actually make it all happen. Now, we are coming to the end of our school sessions now on Mars Day, but it's not the end of Mars Day. We are going to have a small break, but then we will be back at 5:40, so 17:40. But what we're going to be doing is we are going to be meeting some of our international stars, and we're going to be beaming into California, to Washington, to French Guiana, and we're also going to be introducing our guest planet, Jupiter. So there are lots of things coming up. It will be on the same link, so it's the same link all day, and we will be back at 17:40. But for now, I hope you have had a brilliant Mars Day, and please do keep all your socials coming in and use the hashtag MarsDay23. So thank you all very much, and we will be back very shortly. And a big thank you to all of our guests that have joined us in the morning. Thank you.